All right, welcome everybody. Let's go to our modules and see what's going on. If we scroll down to the current week, we are in this week here, week 10, 6 to 12. We did 4.1. It says we're supposed to be doing 4.1 and 4.2, so we're doing 4.2 today. I do want to let you know that I'm going back up to the top. We are going to be using a couple of formulas today. And if we go to week 1, the formula sheet, I think I handed it out in class. If not, if you don't have it, go to week 1 and print this out. Hopefully you have a printer at home. But I'm going to look at this formula sheet. And we are going to be using the compound interest future value formulas, these two that start with A equals, and the compound interest present value, the two that start with P equals. So we're going to be using these today, these formulas. You can, if you don't have the formula sheet, you should have this. I passed it out. If you lost it or don't have it, you can go to week 1 module and print it out there. Right down here, the formula sheet PDF. All right. So let's go to the workbook. Are you guys able to see my 4.2 workbook?
Yes.
Okay, good. All right, so we have to graph this thing here. They just want us to look at the graphs, and we call this graph, by the way, we call this function. Did I hit record already? Yes, I did. We call this function an exponential function. Because it has an exponent, a power. So if it has a power with the x in the power, it's an, if we have 3x to the 2, that's not an exponential function. It has to be an x in the power. So we call this an exponential function, and we want to know what this graph looks like. If you've been watching the news lately with the coronavirus, and they show you these curves, and they're actually using exponential functions. They're showing you that the number of cases of coronavirus are increasing at an exponential rate. Well, exponential means we start off low amount of cases, and then all of a sudden, when more people get it, when 2 people get it, they spread it to 2 others, and now 4 people get it, and then they spread it to 2 others, and 8 people, and 16, and 32, and 64, and it just goes crazy. So an exponential function looks like this. It starts low normally, and then it starts going up and increasing really rapidly. So if you're watching the news and they show you these curves, those are exponential functions. And oftentimes they say, our cases or deaths or whatever they're talking about are increasing at an exponential rate. That means it has a power of x somewhere in this formula they're using. And they predicted the number of cases that we have or the number of deaths, and they lower the case because the curve starts flattening out. And that's exactly in the news, if you're looking, it's an exponential function, but eventually social distancing, it stops and the curve starts flattening out. And then if this is the number of deaths per day, then the curve will go down and there'll be less deaths per day. But right now we're looking at an exponential function where it just keeps on going up higher and higher and higher. Eventually people will stop touching each other and the curve will start going back down. But the exponential function is just the part that goes straight up. And then if you put negatives in front of it and stuff like this that we have, it changes the curve's appearance also. So let me look at I want to look at the first couple of curves before I do this one. don't show, I'm gonna do, I think I'm gonna do, I'm not doing this one first. I'm gonna do an extra one. So I wanted to do a positive one first. So I'm gonna do this one. So I'm gonna do an extra one over here. Or actually, let me just, you can put an extra one over there. I'm gonna use this graph and then I'm going to erase it. But I'm not doing this one right now. I will come back to one and do that. But I wanna just do 3 to the x power. I just want to do 3 to the x power. So the way to do this, don't forget, f of x is another way of writing y. So I just want to put some points in, x and y. So if x is 0, y equals 3 times 0, 3 to the 0 power. And anybody know what 3 to the 0 power equals?
0.
It's not 0. That's why I asked that. Put it on your calculator. People will say 0. Not 3 times 0, but 3 to the 0 power. 3 raised to the 0 power. And what did you get?
1.
Yes, it equals 1. Anything to the 0 power equals 1. Okay, so if x is 0, y is 1. Let's try another x. Let's do x1, x2, and x3. If x is 1, that means 3 to the 1 power is 3. Okay. What happens if x is 2? 3 to the 2 power. 3 squared, 3 times 3 is 9. And we're going to do one more, 3 to the 3rd power. 3 times 3 times 3 is 27. Okay, so I want to do some negative numbers also because we started here. Let me graph what I have right now. 0, 1, 1, 3, and 2, 9. That's not 2, 9. 2, 9 is over here. And then 3, 27, you see it goes way up there. And the graph is just going way up. Exponential goes up faster and faster. 3 to the 4th power is 81. It's going way up there. So now I want to know what's happening on the negative side. So I'm going to put a -1 in there and then a -3 in there and see what happens. So let's put a -1 and 3 raised to the -1 power. Why is my calculator? Oh, I'm normal. I was in a different mode. Okay, 3 raised to the -1 power. And you should get 0.33333. And how about 3 raised to the -3 power? 3 raised to the -3 power. And you get an even smaller number, 0.037. So at -1, it's 0.3333, which is 1/3. It's right here. And then at -3, it's even smaller. It's right here. And if you put in -6, it's really smaller. The number never goes to 0, but it gets really close to 0. And it never goes negative. 3 to the -8 power is a positive number, but it's really small. So this is the graph. It stays there. So do you see? We start off low, really low, and then all of a sudden it shoots up. That's why they're saying, if you look at the news again, I love this, that we're talking about it on the news, that, oh, like in San Antonio, we have 10 cases, then we had 25 cases. I think we have 250, 300 cases. That's not too bad. We're about here. But, I mean, if we didn't social distance, those 250 cases would get more and we'd get crazy. That's why you see these outbursts right now, I think, in Detroit, New Orleans. New Orleans had Mardi Gras, and everybody was running around then. Of course they're going to go crazy and have lots of, because when they were in Mardi Gras, everybody else was quarantining. Everybody was isolating. So New Orleans isolated a little late. So did New York City. They're very close together. So they isolated themselves very late. That's why you're seeing those big outbursts. And I am predicting, they're talking about, there's a couple of more cities, Detroit, Baltimore, that are really going to see these spikes. I am predicting Mexico City. If you've been watching Mexico, the only reason why I'm predicting Mexico City is because I went to Mexico City last Christmas, and it's so big of it's got 20 million people in this city, and I've been watching it and said, okay, we have 100 cases, we have 1,000, we have 3,000. So they have 3,000 cases right now, and that city is so huge. It's gonna go straight up also. So that's gonna be a big one. So this is what our graph looks like. So an exponential function, a number to a power, a positive power, the graph starts off low and goes up high. So that's what that graph looks like. All right, so now let's look at the ones that we have here. Let's look at this one. And the only thing different from this one is it has a negative. So we're going to deal with y equals 3 to the negative x value, x and y. We're still going to put x0, 1, 2, 3, and then we're going to use negative numbers. I'm going to put -1, -2, and -3. Okay, so it's probably a good indication to see those numbers there. So if I put 0 in here, 3 to the -0 power is still 1. And you can try that out. 3 to the negative 0 doesn't have a power, but if you even type in -0, it's still 3 to the 0 power, which equals 1. So next, that negative has to stay there. I'm going to do 3 to the 1 power, which is really 3 to the -1 power. And we already said in the last slide, when we have a -1, that turns to 0.22333. This was end up being 0.037. Remember, we typed that in. I didn't type in -2. If I put a 2 in here, it's 3 to the -2 power. So I'm going to try that. 3 raised to the -2. And I get 0.11. So now I'm going to put the negative number in there. And what I get there is, do you see the negative that's there already? And then a negative number, negative changes to a positive 3 to the 1 power. These two negatives next to each other change to a positive. So this is 3 to the +1 power, and I get 3. And then if I put -2 in here, it's 3 to the +2 power, and I get 9. And 3 to the -3, negative changes to the positive, and 3 to the 3rd power, 3 to the 3rd power equals 27. So let's see what this graph happens when the negative is in front of it. I get 0, 1. I get 1.33, 2, and then I get closer and closer. You could actually look at it. I didn't put all these points in, but it gets closer and closer to the line. -1 equals 3. -2 equals 9. And -3 equals 27. So it's the same graph. That negative, and the one we just did previous to this looked like this. It's the same. The red graph is the one we previously did. Is the same as this one. It just flips over. You just see this part flips over to there, and this part flips over to there, if I drew it correctly. So this is 3 to the -1 power. That negative in front of that x flips it over according to the y-axis. So let's look at the next graph. We're going to see what a +4 does to this graph. But we're dealing with a -3. I wish they'd keep the same graph, but change, just change the stuff that they wanted to. So we are now doing y equals -3x plus another, +4. So this whole thing, by the way, I'm going to put this whole thing in a parentheses because this is the power. The whole thing has to be added together first as the power. So that is the power. So I'm going to do the same thing I did before. I started with 0, then I went to 1, 2, 3. I did some negative numbers. And we'll see if we're able to do this. I think we might need some more numbers, but let's see what happens. If I put 1 or 0 into here, this becomes y equals -3. 0 plus 4 is 4. So -3 to the 4th power is a really small number. -3 raised to the 4th power. Well, I shouldn't say a really small number. It's a negative number. Do you see? It's -3. By the way, this negative is outside of the 3. You know, it's negative. Let me explain this. So what did we put? We put 0 in there, and we got a -81. I want to show you the difference between this -3 to the 4th power and -3 to the 4th power. I'd like you to try both of these on your calculator. This one we just did, you should get -81. But if you put a parentheses around it, you get a +81. The reason why is this power is only attached to one item. This 4 attaches to the 3. So you're taking 3 and multiplying it by itself 4 times. There just happens to be a negative in front. So there's one negative, and 3 times 3 times 3 times 3 is -81. Here, this 4 is attached to the parentheses. So it's -3 in parentheses written 4 times. And an even number of negatives, if you put this in your calculator, you get a +81. So I just wanted you to see the difference between these two. -3 to the 4th power is -81, but -3 to the 4th power, where -3 is in parentheses, is a +81. All right, so we're going to continue on. I'm going to put a 1 in here. 1 plus 4 is 5. I don't know. I think I got the wrong numbers. We're going to actually see what we did wrong. We didn't do anything wrong, but we'll show. And 3 to the 5th power. Oh, Lord, -3 to the 5th power. It's huge. -243. I can't. My graph only goes to 9. So if I put a 2 in there, it goes to 6 power. 3 in there, it goes to 4 power. So I'm not doing those. They're off the chart. But I will do -1. If I put a -1 in here, -1 plus 4 is 3. So -3 to the 3rd power is a -27. That's still too high. If I put a -2 in there, -2 plus 4 is 2. -3 to the 2nd power is -9. And then finally, I'm going to put a -3 in there. -3 plus 4 is 1. -3 to the 1 power is -3. So I'm going to put these in my graph. 0, -81, it's down, it's off the chart. I can't even write it in. 1, -243, I can't even write it in. -127, I can't write that one in. -2, -9, I can put that one in. That's right there. And -3, -3, -3, I can put that one in. Okay, so you see the graph was going way down. So I'm going to put some more negative numbers in there, and I think that will help. Let's put -4 in there now. -4 plus 4 is 0. -3 to the 0 power is actually, because only the 3 is the 0 power, which is 1, which is -1. Put that in your calculator. -4, -1. Okay, let's try -5. If I put a -5 in here, -5 plus 4 is -1. 3 raised to the -1 power, and I get -0.333. So at -5, I get here. At -6, I get even smaller. If you put these numbers in, you'll see you're going to get even smaller. So you do have an exponential curve, but it's exponential going down, if I could have drew it correctly. So if you look at this, it goes down, and it goes way down really fast. You saw at 0, it's all the way down to -81. At 1, it's way down there. So this graph is exponential going down there. All right. So now that we've seen a couple graphs, is that it, or do I have to do more? Oh, we do have to graph this transformation where appropriate. Remember, our graph, exponential graph, our standard, the one we did, y equals 3 to the x power, our standard exponential graph looked like that. Our standard exponential graph, let me be a little, it goes through this point. Let me erase it. I wanted to make sure we saw that our standard exponential graph looked like that. It went through here, then it went up. Now, what they want you to see is that the other transformations, a -1 on the outside should move this graph down one spot, right? A -1 on the outside should move it down. So let's do this graph, 2x -1. That -1 is not a power. That -1 is not a power. It's outside of it. So I'm going to do the x and the y, and I'm going to do 0, 1, 2, 3, and -1, -2. If I put 0 into this function, 2 to the x -1, and if I put 0 into here, 2 to the 0 is 1. 1 minus 1 is 0. If I get 0, 0. There, I'm gonna do it in a different color. If I get 1 into this function, if I put 1 in there, 2 to the 1 power is 2. 2 minus 1 is 1. If I put 1 into it, my x is 1 and my y is 1. There we go. Let me try the next number. If I put 2 into the function. 2 to the second power is 4. 4 minus 1 is 3. So 2, I get 3. And then I'm going to put 3 in here. 2 to the third is 8. 8 minus 1 is 7. So if on 3, I go up to 7 right here. So there's my graph, exponential. I don't think I drew the black one quite right, but that's okay. And then if you do some negatives, let's put -1 in here. 2 to the -1 power is actually, if you look at it, is 1/2 or 0.5. 0.5 minus 1 is a -0.5. And then I'm going to put -2 in here. 2 to the -2 power is 0.25. Minus 1 is -7. 25, and minus 1 is a -0.75. So at -1, we get 0.5, -0.5. Here we get, I think we get this, right? And what happens is our graph looks the same. Our graph ends up looking the same, but it's just shifted down one spot. If I would have drew the black graph a little bit better. I mean, our black graph should have been like this. If I could draw it at 1, and then at 1, we went to 3, and then we went to 9. There we go. So this was what our black graph was looking like. And there's our other graph. This could have went up straight. So this plus -1 just moved the graph down 1. And it's a little different. We had a 3 and they had a 2. So it looks about the same if you look at it. It just kind of like shifts, that -1 shifts the graph down just like we did previously with our shifting of the graph. All right, so the next part, there's a little algebra involved. So all of these problems that we have now, we have to learn a new concept. I want to show you. See, they always start with these harder problems. So I'm going to start off with an easier. Yeah, these are all hard. Not hard, but they're not a standard basic, very basic problem. So I'm going to start off with a very basic problem. 2 to the third power let me see. Check on your calculator. I just want to make sure everybody understands 2 to the third power does equal 8, correct? Everybody, I mean, if you put 2 raised to the third power on your calculator, it does equal 8. What we're trying to do, so in this section, we're solving exponential equations. In other words, x is in the top of the power. We're solving exponential equations. We're going to solve for x. We're solving for x, exponential. Step 1 is make bases the same. So when I say 2 to the third power, 2 is the base, and 3 is the exponent or the power. So our first step is make the bases the same, okay? So, and I mean, we're going to write this down. We're solving exponential problems. Our first step is to make the bases the same. If the bases are the same, then powers equal each other. So watch, I'm just gonna, I mean, this is very basic. 2 to the third equals 8. Another way of writing 8 is we want to make the bases the same. Here I have 2 to the third. Over here I just have an 8. I can write 8 2 to the third. I want you to see our goal, even though there's no x in this problem, but our goal is to make these bases the same. They're both powers or bases of 2. And then, oh, by the way, this is 2 to the third power. And then if the bases are the same, if we can get the bases the same, then the powers equal each other. That's the whole process here. If the bases are the same, then the powers equal each other, okay? So let's try these problems now. Oh, Lord. So you have to use maybe your calculator or something. I'm going to do number 5 first. I'm going to do number 5 first. I think number 5 is a little bit easier. This is the power of 4. On my calculator, I'm going to do just trying something out. 4, I'm trying something out, yeah, with 256, by the way. I'm going to try to find something with 256. 4. So let me show you what I'm going to try out. I'm going to actually get it on my calculator. I'm going to show you the calculator. So on my calculator, if you can see it, you might have to, if you double click my calculator, does it make it bigger? So I'm using the base of 4 over here, and I'm trying to get it to equal 256 somehow. 4 raised to the third power is 64. No. 4 raised to the fourth power is 256. So I have 4 raised to the fourth power, 256. Okay, so I needed my calculator to verify that. So, okay, that sounds good to me. Now I can come back to the problem. If I can get it back. Where am I? There we go. So if I can get my bases to both be 4, I know this down here is 1 over 4 to the fourth power. So I'm going to just rewrite it. This is 4 to the negative x equals 1 over 4 to the 4. 4 to the 4 is 256. That's why I have that on the bottom. Now, my bases are not the same because this 4 is on the bottom. Anybody know how I can get this 4 to the top? Anybody remember a rule of the exponents we had where I can get that 4 to the top? All right, let me show you then. We have to know this rule. 3 to the negative 3 power is actually this negative when we have let me start off with an x. If we have an x to the negative 3 power, This negative power, if you have a negative power, it flips it. This negative says whatever it's attached to this x. This x now flips to the bottom. The power of 3 is still attached to the x. The negative just flips it to the bottom. If I had 1 over x to the negative 2, this negative power now flips it. It brings the x to the top, but the power of 2 is still attached. Once you bring it to the top, once you flip it, the negative sign disappears. So, in this problem, I have 4 as my base. I have a 4 here, but it has a 4 power. I need to flip this 4 to the top. If I change it, so we have 4 to the negative x here. If I change this to 4 to the negative 4, do you see if I put a negative in there, it flips it to the top. The negative's not on the bottom, but when I put a negative, it then flips it. So if there's a negative, it flips it down. If it's a positive and I put a negative on it, it flips it to the top with the negative on it. So now I have the bases are the same. The bases are both 4. So step 1 is done. Make the bases the same. The bases are on top and they're both the same. If the bases are the same, then the powers equal each other. Then we have to say negative x equals negative 4. If the powers are the same, then if the bases are the same, then the powers have to be the same. And then I just get this negative to the other side by dividing by negative 1. And x equals negative 4 divided by negative 1 is 4. So the answer to this problem is x equals 4. You make the bases the same, then the powers equal each other, and you solve for x. Maybe I should add that into this. And then step 3 would be solve for x. All right, so we did number 5. Let's do number 4. I know now 9. 9 is 3 to the second power. Right? So I have to make it with a power. I know 9 is 3 to the second power. If I flip it, if I put a negative in front of it, if I flip it, then when it's on top, it's a negative. Do you see? If I flip it to the top, it's now negative. And now if I flipped it back to the bottom, the negative would disappear because then it would look like back to the way we had it. So the left side is 3 to the negative 2 power. Check to see if 729, check on your calculator, if somehow you can make 729 3 to some power, because you have to make those bases the same. So I'm going to try on my calculator 3 raised to the 4th power. Oh, that's 81. That didn't work. 3 raised to the 5th power. Oh, that's 243. That didn't work. 3 raised to the 6th power. So on your calculator, 3 raised to the 6th power equals 729. So do you see 729 equals 3 raised to the 6th power? We didn't have to flip nothing. It was on top already, so we didn't have to change the sign. So step 1 is done. The bases are the same. By the way, this is 3 to the negative 2. We brought it to the top. This is 3 to the negative 2. But it still has an x in front of it. I just didn't put x as a power in front of it, okay? So we're almost there. I'm going to erase this part. We're at this part right now. 3 to the negative 2 power raised to the x equals 3 to the 6th power. All right, there's a rule when you have a power and it has a power. When you have a power that has a power, you can multiply those two together. So you need to know that exponent rule. I think we went over these. I'm not sure. I'm hoping we went over these. Power raised to a power, you multiply. -2 times x is -2x. Now I have the bases the same. Step one. Do you see the bases are the same? And if the bases are the same, then we make the powers equal to each other. So on the other, right here, I'm going to say the powers, -2x, has to equal 6. The power has to equal 6. And if you divide both sides, get rid of, we're solving for x now, to get rid of the -2 by dividing by -2, divide by -2. I end up with 6 divided by -2 is a -3. The answer is -3. X equals -3. All right, so I want you to try this on your calculator. We have 1/9. On your calculator, hit fraction. Let me change my mode. I messed it up. Hit fraction. Oh, I'm going to do it on my calculator to show you. On my calculator, I'm going to hit, and when I do a fraction like that, I'm going to put it in parentheses, 1 divided by 9. 1 divided by 9, and I want to raise it to the -3 power. Raise it to the -3 power. So I have that. And when I hit enter, I get 729. So yes, 1/9, if I put -3 in there, I do get 729. So that is my answer to this problem. So you can check it by putting the answer back in there, into the original problem. Everybody okay with this so far? We have a couple more to do. Good. We have a couple more to do. All right. Number 6. So number 6 already has a base of 4. Let's see if I can create a base of 4 out of 256 on my calculator. Are you guys able to see the calculator when it's like that? Can you make it bigger? I'm not sure how that works.
Yeah, I just double click.
And it comes up good. All right.
Yeah.
So 4 raised to the 3rd power equals 64. That didn't work. 4 raised to the 4th power equals 256. So do you see? 4 raised to the 4th power is 256. So over here, I have 4 and parentheses 8 minus 2x. That whole thing is a power. 256, we know from my calculator, is 4 raised to the 4th power. So the bases are the same. If the bases are the same, then the powers have to equal. And the power is 8 minus 2x, and it has to equal 4. Do you see? These two have to equal each other. 8 minus 2x has to equal 4. So we solve for x next. Step 3 was solve for x. You have to get the 8 to the other side and the -2 to the other side. Somebody tell me, which one do you take to the other side first? When we're solving for x, this is adding to the side. This is, the -2 is,
8.
yeah, it's multiplying. You always take the add and subtract to the other side first. So I'm going to subtract 8, and I get -2x equals 4 minus 8 is a -4. Then I have to take the -2 over. It's multiplying, so I'm going to divide by -2, divide by -2. And I get x equals -4 divided by -2 is 2. That's my answer. If I put 2 into here, 8 minus 2 times 2, 2 times 2 is 4. 8 minus 4 is 4. 4 to the 4th power does equal 256. So do you see, you can plug the 2 back into the original problem and check it to make sure that is correct. Make the bases the same, and then the powers equal each other. All right, let's see what's next. Same thing. Oh, this is a good one. 9, let's try this on my calculator. I need to try to get 27 to be the base of 9. So I'm going to do that right now. I'd like to make my screen a little bit bigger over here, just so. So once again, if you, 9 raised to the 2nd power is 81. 9 raised to the 3rd power is 729. There is no way, even 9 to the 1 power is 9. 9 to the 2 power is 81. There's no way 9 to any power is going to be 27. So 9 will not work as a base. So what this tells us, 9 doesn't work as a base. However, we got to try a different base. I do know that 3 to the 2nd power equals 9. Do you see? I just changed 9 to the 3 to the 2nd power. 3 times 3 is 9. It still has a power of 6 plus 3x attached to it. And I do know 3 to the 3rd power is 27. So it looks like I'm going to use a base of 3. Now, this 3 is on the bottom of the fraction. I have to bring that 3 up to the top. The only way to bring it to the top is by putting a negative on that power. That negative flips it to the top, and it has a negative on it now. If you have a negative and you flip it down or flip it up, if it's a negative already, the power goes away. If you don't have a negative, like we don't have one here, when you flip it, the negative goes there. So now I have a power of 3. Powers are the same. The bases are the same. Bases are the same. These bases are the same. The powers should equal each other. 2 times 6 plus 3x should equal the power there, -3. This power needs to equal that power. And oh Lord, let's see how I'm going to do this. I'm first, so we have to solve for x. I'm going to go through and distribute first. I'm going to distribute this. And I get 12. 2 times 6 is 12. 2 times 3 is 6x. Then I'm going to I have to take the 3 and the 6 to the other side. I'm going to start off with the 12. Did I say 3 and 6? Take the 12 and the 6 to the other side. I'm going to start off with the 12. And 12, you have to subtract. It's a plus 12, so I'm going to subtract 12. When I get that, I end up with 6x equals -3, and a -12 is a -15. Then I divide by -6. Divide by a positive 6, sorry. I'm dividing. And x equals -15 over 6. If you reduce that on your calculator, x equals -15 over 6. By the way, you can actually put that in your calculator. -15 divided by 6. on my calculator, or you can hit the fraction button. Negative 15 over 6. When you negative 15 over 6, when you hit enter, it reduces it for you. They both divide by 3, and it reduces the negative 5 over 2. So you want to reduce fractions all the way, negative 5 over 2, because on a multiple choice test, 15 over 6 would not be on the test. It would be negative 5 over 2, and you have to be able to convert it correctly. So in this case, the answer is x equals negative 5 over 2. All righty. Okay. Oh, we have another one. Oh, no. How many of these do we have? We have 3, 4. Wow. Okay. So let's do this one now. And once again, I start off with a base of 8. And if on my calculator, I do 8 to the 1 power is 8, 8 to the 2 power is 64. And I've already passed 16. Do you see 6? I thought maybe 8 to the 2nd power was 16, but it's not. 8 to the 2nd power is 64, 8 times 8. So I cannot use a base of 8. I can't use a base of 8. So I need to take 8 and change it to a different base. By the way, you should start off with 1 and then see if you can make the other one. So 8, if I can't use 8, 4 to the 2nd power is not 8, it's 16. So I can't use 4 as a base either because it doesn't change to 8 anyway. I do know 8 is 2 to the 3rd power, 2 times 2 times 2. So I do know 8 is 2 to the 3rd power. Okay. So I can change this. 8 to 2 to the 3rd power. That's my 8. It still has 2x minus 1 as a power. And then if I go to my calculator, 2 to the 3rd we know is 8. 2 to the 4th is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 changes 2 to the 4th power. And I'm putting that in parentheses because that is 16 and the other parentheses is 8. And then it has a power. By the way, we want to keep that power in parentheses, 3x plus 4. Okay, so we do have base of 2 for each one. And I'm going to rewrite these because this is a power and this is a power. This is a power and this is a power. Our bases are 2. So if I'm going to rewrite it now, 2, let me change my color. 2 to the 3rd power, and then it has 2x minus 1. Over here, I have 2 to the 4th power and 3x plus 4. So it looks a little bit better where I have my bases. If I have my bases, then the powers equal each other. So over here, 3 times 2x minus 1 equals 4 times 3x plus 4. And we have to solve for x. Let's distribute. 3 times 2x is 6x. 3 times a negative 1 is negative 3. We're going to distribute here also. Uh, 4 times 3 is 12x, and 4 times 4 is 16. Okay, so we distributed. If you remember solving for x, you now have to get all the x's to one side using add or subtract. If you remember all your steps for solving x, I'm going to get this x to the other side. When you get all the x's to one side, you can only use add or subtract. So it's a positive 6x, so I'm going to subtract 6x to both sides. And I end up with, that turns to 0. I end up with negative 3 equals 12x minus 6x is a positive 6x. Now I need to get x by itself. I need to get rid of the 6 and the 16. You always take the add and subtract to the other side first. So I'm going to subtract 16, subtract 16. I'm left with 6x equals negative 3 and a negative 6. 16 is negative 19. Did I do that right? Yeah. And then I'm going to divide by 6. And x equals a negative divided by a negative is a positive 19 over 6. And you can check to see if that reduces or not. It doesn't reduce. That is my answer. So we got a crazy fractional answer that time, but that's okay. It still works. And by the way, if you put 19 over 6 in both of those x's up there, I'm not going to do it. Put it in your calculator. Both sides should equal each other. And that's how you would check your work. All right, so now we have to do those formulas that I showed you earlier in problems. So if you have your formula sheet out, let's take it out. And it's kind of important. It says find the future value. So if you look at the formula sheet, there are 2 future value formulas. I'm going to write them here at the top. A equals P 1 plus R over N raised to the NT power. Now make sure that NT is in parentheses when you write that down. I'm sorry, it might be a little bit high. A equals P to the 1 plus R over N raised to the NT power. So put that power NT in parentheses. I know on your formula sheet it's not in parentheses, but put it. So by the way, A stands for annuity, which is the future value. Future value is A. Present value is P. So A is called the annuity or the future value. P is the present value. Or T is the time in years. And it always has to be in years. Time has to be in years, okay? And then finally, N is the number of times compounded. When you put money in the bank, let's say you have $1,000 in the bank. At the end of the year, if you don't do anything, let's say you have $100 in the bank. This is going to be easier. You have $100 in the bank, and the bank gives you 1% interest. Let's say 2%. Your bank is really nice, and they give you 2% interest. If you put $100 in the bank and it gives you 2% interest, it calculates at the end of the year, it calculates how much interest you have. You had $100. They give you 2% interest, and they compound your interest. They check it out, and 100 times 2% is $2. So at the end of the year, at the end of 1 year, you have $102 in the bank. So you have more than you started with, because the bank gives you money so they can borrow you. They can give other people loans with your money, and they give you some of that money. Very little of the interest is yours. Most of it goes to them. They don't tell you they're loaning other people your money, but they are. That's why they give you a little bit of money. You know, normally on your monthly statement, you might see, oh, you've added 3 cents to your account. That's the money the bank's giving you because they're letting other people borrow it to buy a car or a house. And they give you a little crumb and they take the rest of the cake. Now, some banks compound interest once a year. That's very few now. However, some banks calculate, and if you look at your monthly statement, some banks calculate your interest and add your interest to your account every month. So they compound the interest 12 times a year. So I'm going to put this over here. So n equals 1 when they compound annually. They compound it once a year. They can do it semi-annually. Semi-annually means they compound it, they add the interest to your account 2 times a year. They can also compound your interest, and most banks do this, 12 times a year, every month. There are 12 months in a year. Sometimes they get crazy. Very few banks do this. Most banks do monthly. Sometimes they do it weekly and they compound your interest. They add your interest to your account 52 times a year. Every week they add a little bit of money to your account. Sometimes, you need to write these down if you don't know this, because you're going to be using this throughout this test. If it's daily, there are 364, 365, something like that, days in a year. The bank doesn't use that. The bank uses, they call it bankers' days. They just use 360. They round it to 360, depending on a leap year or not. So if they say they compound it daily, we use n equals 360, okay? And then there's also banks that compound it continuously. And that's a different formula. That's that other formula, different formula. So this was the one formula we're going to be using for this problem. But if you look on that sheet, compounded continuously, these are all the n's that we're going to be using. But if it says continuously, you have to use that other formula, A equals P-E-R-T. And we're going to look at that. This is the continuous compounded future value formula, okay? So now that we know all of this, we can do the rest of these problems. All right, let me erase this and let's start the problems. This is taking longer than I thought. So we were trying to find the future value. Present value, this is how much I'm investing right now, 1972. The formula is 1 plus R, the interest rate. The interest rate is 4%. R is the interest rate. I didn't mention that. Interest rate. 4%. N is the number compounded. Oh, I didn't say quarterly. So remember annual, N equals 1. A biannual or semi-annual, N equals 2. Quarterly, N equals 4. Quarterly means 4 times a year. There are 4 quarters in a year. So we put a 4 here, raise it to a power, N is 4, and T, the number of years we're going to do this, is 12 times 12. So this is what I'm putting in my calculator. And it has to look exactly like this with the parentheses, or you may get it wrong. So I really recommend practicing this. Try this, and if you're not practicing it now, you don't have your calculator now, watch the video and practice it with your calculator to make sure you can type it in correctly. So let's type this thing in. On my calculator, I am typing in 1972. Well, let me clear that. 1972, parentheses, 1 plus a fraction. I'm hitting the ND button, and I'm going to put 4%, 4, and then I'm hitting the percent key here. 4% is on top. I arrow down to the bottom, and I have to type in 4. Arrow over to get out of the fraction, close my parentheses, and then I have to raise it to a power. I'm going to use the arrow button to raise it to a power. My power is going to be in parentheses. Please put your power in parentheses. I think it helps out. And it's 4 times 12. Close parentheses. So that's what you should have typed into your calculator. And it should look just like what I wrote down, right, on the paper. And when you hit enter, did you get 3174.3098? 3104.7. Is that what I got? 31. That's not what I got. I can't see what I got. I got 3179.309. Now, we're talking about money here. We always round money to 2 decimal places, to cents. So this is 3179. Since this is 5 or more, the number to the right is 5 or more. I have to add 1, 0.31. So if I put $1,972 in the bank now, and the bank gives me 4% interest compounded quarterly, 12 years from now, I will have $3,000 in the bank. Wow. So the bank gave me a lot of money. Gave me over $1,000, but you want to put $2,000 in the bank and then get it 12 years from now, and now it's $3,000. You probably can't, 12 years from now, you probably couldn't buy as much as you could have with 1972, with 2,000. Did anybody try that and actually get the same number as I did?
Yes, sir.
Good. And everybody out there, if you haven't tried it, try it. This is the hard part, being able to type it in your calculator correctly and getting the answer. I mean, so many people mess this up because they maybe don't put the power in parentheses, or maybe don't type in the percentage sign. You have to type it in correctly, and you have to practice these. So when it's time, because these get actually a little bit more complicated also. So that's that one. Let's go to the next problem. How much should be invested 4 years? Okay, we're using the present value formula. See, what was the first one? The first one, we used the future value formula. How much we're going to have in the future. See, here we want find the present value. How much should it be invested now? That means we're trying to find out what P equals. The other one was, how much are we going to have in the future? What does A equal, the future value? This one, how much should we invest now? We want to know how much the present value, how much do we put in the bank now? So in the future, this is A, it will grow to 11,000. So, and we're only going to get 3%. R equals compounded monthly. When we say compounded monthly, N equals 12. T equals 4. So we have everything we need. We just need the present value. We want to know what P equals. Look at the formulas, and here it says P equals, I'm writing it really too big. I'm getting excited. When I talk about math, I always get excited. P equals A, 1 plus r over n parentheses. And then we have, I put a parentheses around that power, negative n times t. So this is the formula we're going to use. We're trying to find p. So first we put a into the formula. We already said a was 11,000. 1 plus r, the interest rate is 3%. N is compounded monthly and is 12. The power, n, is 12. There's always a negative in front of this formula, so you still have to put a 12 there. And then time is 4 years. So this is the way I should be typing it in my calculator, and it will tell me what P equals.
Mr. Troutman, on the previous question, did we put a negative
No,
in?
no. Look at the previous. If you have your formula sheet, the previous formula. This was the previous formula. The previous formula was A equals P 1 plus R N N T. There's no negative in that. In this one, that's finding the future value. This one, we're finding the present value. It's a different formula. There are two different formulas on the formula sheet. It's really important to know if you're looking for the future value or the present value. And if it says how much should be invested, that means how much do I put in the bank now? That's present. So that's why we're looking for P in this problem. So let's put that into our calculator. On my calculator, 11,000. Parentheses, 1 plus a fraction, 3%. Arrow down, put a 12 down there, n is 12. Arrow over, close that parentheses, raise it to a power, put the parentheses for the power, and it should be negative 12, not subtract 12, a negative 12 times 4, close the parentheses, and when you hit enter, you should get 9757.585. So I get a P equals 9757.585. So we always round into 2 decimal places. So we always write down 3 decimal places to see if we add 1 or we don't add 1. 5 or more, you add 1. So the answer is 9757.59. So if I put $9,757.59 in the bank now, 4 years from now, I will have 11,000. Do you see? It says, how much do I put in the bank now? So 4 years from now, I can have 11,000. At 3%, I put $9,757 in the bank. That will do it. Okay, it's really important when you read these questions to understand, am I looking for A or am I looking for P? Am I looking for the present, how much money I'm putting in the bank now, or how much money I'm going to have in the bank in the future? I mean, you know, that the A is how much it's going to be in the future. P is now, present. All right. Find the required annual. Oh, no. Where's that formula sheet at? I'm going back to the formula sheet. I think I have to teach you some other stuff now. I'm going back to my formula sheet. I don't think they have everything I thought was going to be easy. Let's look at the formula sheet. Let's see what's on here. I just have compound interest. That's it. All right. So we have a little extra work to do here for this problem. Let me see what the next problem is really quick. I want to do number 12 first. I don't know if I'm going to do the other one. I probably will do the other one. I'm going to just want to do number 12 first. Number 12 is easier. Okay. So let me get to number 12. Number 12 says, suppose 4,000 it is invested. So as soon as you said 4,000 is invested, that means I'm putting the money in now. That's my present value. This is R, compounded continuously. As soon as you see this, it's a different formula. And the number of years time equals 3. Okay, so we want to know how much will be in the account. How much is the future value? We want to know the future value. So on your formula sheet, you have to look for A equals, but it has to say continuous. So the A equals continuous formula is P E R T, and I always say all powers. If there's more than one and a power, you have to have that in parentheses. So this is the formula I'm looking at on my formula sheet. We're looking for how much we're going to have in the future. We have everything else. P is 4,000. And then there's this E thing. And R is 7%. And we're going to multiply it. RT is R times T. T is 3 years. So we have to put this in our calculator. Okay, so let's look at our calculator. There is an E button here. It says E to the, oh, where is it? I thought there was an E button there. Where is it? I got to look at it now. I can't see that far away. There is an E button here somewhere. Help me. Anybody see an E to the X? Oh, I see it.
Top left.
Yeah, on the LN. It's in green right there. It's in green, E to the X. Watch, if I hit second LN, first I got to turn my calculator on. Second LN, do you see E pops up? LN is E to the X. So second LN gives me that E. So to type this into my calculator, we have to type in 4,000. Then we need that E button, second LN, parentheses, since we're in the power now. See, it already took us to the power. We don't have to raise it. Parentheses, 7% times 3. 3 years. Close that parentheses, and you should have it typed in like this on your calculator. And then just hit enter, and it tells you how much you'll have in the future. If you put $4,000 in the bank now at 7%, 3 years from now, you will have $4,934.71. So our future value, we had put 4,000 in, we have $4,934.712. So we always round our decimal to 2 places. 4 or less, you don't change anything. Just leave it at 71. If it was 5 or more, you would add 1 to that cent. So once again, if I put $4,000 in the bank, I will have $4,935.71 at the end of 3 years if the interest is compounded continuously. Which means your computers are adding up your interest all the time. All right, so we're going to go to the hard one now. If it is a hard one, it's a hard one. I wish they would have did this after. after we did the next section, because the next section, I think, shows us how to do this. This problem says the interest is compounded quarterly, so we're not going to use the continuous. N is 4. T is 5. Find the required annual interest rate. We're looking for R in this problem. For $5,200 to grow to 65. 65 is how much it's going to be in the future. It's growing to that much, and this is how much we presently have. We presently have 5,200, and it's growing to 65. So if you look at any one of those formulas, we're using compounded. I'm going to use the future value. A equals P. By the way, you could use either one of these, but I'm going to use A equals P1 plus R over N to the NT power. And I'm going to fill in everything I know. We know A is 6,500. P is 5,200. R, we don't know. That's what we're trying to find. N is 4. And the power is N, 4 times the number of years, 5. Okay. So let's rewrite this. 6,500 equals 5,200. 1 plus R over 4 to the 20th power, right? 4 times 5 is 20. Okay, so this, so you're gonna watch this, but we're gonna actually, I think we're gonna learn this more next time. I need to take the 5,200. I'm trying to solve for X. I'm trying to find out what R equals. So I need to take the 5,200 to the other side. It's multiplying times that parentheses. So I need to divide both sides by 5,200. And I'm not going to actually divide anything on my calculator yet. I'm going to do it all at once or you'll get it wrong. So I'm going to divide this side by 5,200. And I'm going to divide this side by 5,200. So that cancels. And on the left side, I have 6,500 divided by 5,200 equals 1 plus R over 4 raised to the 20 power. Okay? Okay, so now watch what I do because this is a lot of stuff that we haven't done. This is in parentheses, so I'm just going to put this in parentheses to show you this. I want this 20 to be a 1. I don't want a power, right? 5 to the 1 power is 5. 6 to the 1 power is 6. I need to change this power to a 1 somehow. If I multiply the power by 1 over 20, 20 times 1 over 20 cancels out, and I am left. 20 times 1 over 20, I'm left with a 1. That's what I wanted. So if I multiply the power on this side by 1 over 20, and when there's no power there, it's like there's a 1. So if I multiply this side by the power of 1 over 20, I'm left with 6,500 over 5,200 raised to the 1 times 1 over 20 is 1 over 20. Okay? If you have a 1 power, you can erase it because it just means, 6 to the 1 power is 6. 5 to the 1 power is 5. So this is what we ended up with. My goal is to find out what R equals. I have to take the 1 to the other side and the 4 to the other side. You always take the add and subtract to the other side first. So I'm going to subtract 1, and I get 6,500 equals 5,200 raised to the 1 over 20 minus 1 equals r over 4. Oh, Lord. Now I need to get the 4 to the other side. I'm going to erase some stuff to make some room. The only way to get the 4 to the other side is it's dividing by 4. So the opposite of dividing by 4 is multiplying both sides by 4. I'm going to multiply. You got to multiply, put a parentheses and multiply both sides by 4. What happens is I ended up with this number, 6,500 over, I don't even know, 6,200, 5,200. I can't even read my own writing. Raised to the 1 over 20 minus 1. But the whole thing has to be raised or multiplied by 4. You see, the whole thing is multiplied. It's not a 4 power, it's just a 4. We just multiplied by a 4. So we're going to put this into our calculator and see what we get. It's a lot because it's like all these double parentheses and everything. You really need to put that minus 1 in parentheses like that because you're multiplying the whole thing by 4. So on my calculator, I'm going to put parentheses and then another parentheses with a fraction. 6,500, go down to the bottom. Oh, go down to the bottom. 5,200, arrow over, close that parentheses, raise it to a power, and I'm going to put it in parentheses. The power is a fraction. 1 over 20, arrow over, close that parentheses. Oh, no. I got to arrow over again because it's subtracting 1. We're not subtracting 1 from the power. We're subtracting 1 from the whole problem. Closing that parentheses and then multiplying it by 4. So it's a lot. And when I type it in, I get 0.0448. When I type it in, I get an R of 0.0448. It says, it tells us to the nearest tenth. Tenth is 1 decimal place. But don't forget, this is a decimal number. We need the interest rate. Remember, the percentage. To find a percent, you multiply by 100. So R equals 4.48%. But it says to the nearest tenth. That means 1 decimal place. Look to the right. You have to add 1. So my R equals 4.49%. That's a tough one. In your book, if they give you a formula for R equals, if you see a formula for R equals already, use that and plug everything into it. They didn't give it to us on this formula sheet, but your book, your homework might give you a formula. Look for the help. If they give you an R equals formula, use it, and then you won't have to take everything over to the other side. Unless if they don't use it, if they don't have that R equals formula, then you have to do what I just did by first plugging everything in and taking everything to the other side by doing the opposite. All right, that's all I had for this section. Just hit